my name is Dennis Sang. This is my final project presentation for DSC 478. So basically what I did was a continuation off of the final project that I did for DSC 441, in which I looked at classification of NFL regular season drives. And so going into this, in order to kind of make this final project worthwhile, I thought about what exactly I wanted to do to make it a little bit more robust in terms of just improving performance, as well as to see whether or not I could look and compare data, compare and predict drives accurately for playoff drives. So generally, the work that I did in DSC 441 was based in R, and so I converted most of the code into Python so I can do some data manipulation in Python a little bit better. Generally what you see is, for the most part, the process is very similar to the previous project, with some key distinctions, which I'll get to really quickly. Basically, what we're trying to do is take the raw play-by-play regular season data from 2009 to 2018, and we essentially do two steps of processing. So the first thing that we do is, so I call it pre-processing, which is to process the play-by-play data. This means removing any columns that are unnecessary, removing any duplicate rows, determining whether or not we need to do some feature creation or to kind of handle null values or do some value imputing, which we don't necessarily need to do a lot, but if necessary. And then basically to clean everything up, and that's step one. And so as you can see, what we essentially do is we pull out a lot of characteristics from the play-by-play data in order to kind of throw it back in once we have grouped everything into the drives. So what's kind of new in this project, or at least for this final project, is that we're incorporating team-specific drive data. And so whereas the other data set came from, essentially, it was scraped from the NFL Live Game Center API, we're pulling team-specific data from Pro Football Reference, and to kind of like take a little bit of a view. Essentially what we can do is see that for any particular year we have 32 teams, as well as the grouped aggregate stats for passing defense, rushing defense, conversions, and most importantly how they perform per individual drive. And so what we do is we scrape that data from 2009 to 2018 so that we match the years. We load this data, and we take all the tables that we see in this particular page, we merge everything, and then we pull the same on the offensive side, so we both have defense and offense. And the end result is, after doing some analysis, is we take that and we merge it back into this drive data set once we create it. And so one of the things that we've noticed with the drive data is that a lot of, through feature creation, or just because the game of football is very interconnected, that we find a lot of correlations between a lot of the features we have. And so rather than try and remove this through feature selection or feature extraction, what we ended up trying to do is, once we incorporate all the data, is to first scale it so that all the data was scaled equally, making sure that we also create dummy variables so that we handle nominal variables. When we perform PCA analysis, and then we know that from our results that 31 components capture at least 90% of the variance in the data. And so using this data set, we start moving forward to try and do some modeling to try and classify drives using the regular season data. Now, to compare to the old project, because it was coded in R, what I did instead was I took the new drive data set, which incorporated team-specific data, and also kept a copy of the old data set, which doesn't have the team-specific drive data. And for each classification technique, ran it on both the new drive data and the old drive data, and then compared the performance metrics that are that we find important, which are accuracy, as well as precision on one class in particular, which is the touchdown class. And so, as you can see here, this is the class that we're very interested in. And so we compare it for the old and the new data set, so that we're seeing whether or not the new data set, the data that we've incorporated, is actually helping our models. But then we're also taking the techniques that we use, decision tree and KNN, and we're also looking at random forests. So essentially what we did is use 6 different classifier models, 3 different types of algorithms: random forest classifier, decision tree, and KNN, but also testing it across the new data set and the old data set. And so what we can see is that when we look at the feature importance, especially on the new data set, because there are 31 components, that when you look at the scree plot, if you notice on the y-axis that the feature importance is obviously these are these 5 components. First 5 are the most important, but the most important, the totaling up is less than 50%. And so when you look at this, the individual components itself, obviously for the most important component, you can see that actually runs and rushing are quite important, whereas in the current scheme of the current game strategy for modern NFL, passing seems to be the in vogue. But what the thing to keep in mind, though, is that because there are so many components within the model, especially for when we look at the random forest performance, it's very hard to say that, well, rushes, everybody should focus on rushes. So rather, the approach that we're kind of discussing is that, based on the results, it's important to kind of make sure that that rushing performance and rushing strategy is not neglected when it comes to modern NFL game strategy. And so what we can see after we kind of perform everything is that they all perform pretty similarly, but the random forest actually provides the best performance when it comes to accuracy and precision. So one of the things that we do after this is I wanted to test whether or not playoff data is relevant. So we've essentially had another validation data set on the playoff data, and we have to do the exact same thing where we clean the playoff data and group everything in the exact same way. So this process is virtually 100% the same, and then we run just the new classifiers, so on the new data, including the team drive specific data sets. And what we find is that the decision tree, the random forest, and KNN all perform relatively well, but the clear-cut winner in this case is the random forest, which is pretty interesting just because I think based on the nature of random forest, which is just an ensemble of a lot of decision trees, I think it doesn't overfit in the way that maybe the decision tree is. And then when we look at KNN, its the performance is quite low. Specifically, if you look at the precision on touchdown class prediction, it's quite poor. 0.25 is not that great. So to sum it up, we essentially trained. We first took play-by-play data from the regular season for about past 10 years. We grouped them into drives, and we did some exploratory analysis, and then decided to classify them on decision trees, random forests, and KNN, and doing another layer to make sure that the new data that we incorporated for this final project is better than the data that we initially prepared for the previous on our project. And ultimately we find that the new data is actually better, and then that the random forest classifier performs the best, especially when it comes to playoff data.